Hi, I'm Prof L and welcome to Chemistry Matters. And today we're going to be looking at a couple of stoichiometry problems, one of which is not unrelated to all of those beautiful green trees and foliage and stuff that you can see behind me, because we're going to be talking about chlorophyll. So, chlorophyll is a very, very large molecule, and it has the chemical formula C55H72O5N4Mg. So there's a lot of atoms in one molecule of chlorophyll. So the question that we're going to be asking today is this: what mass of oxygen is in 1 gram of chlorophyll? And how do we start this? How do we begin? As I have alluded to in other videos, whenever you've got a stoichiometry problem and you don't know where to start, a very good place to begin is to look at the data that you've been given and see what you can figure out from that. We look at our problem and ask ourselves, what data have we been given and what can we do with those data? So it looks like here we've just been given the one thing. We've got 1 gram of chlorophyll. What can we do with one thing? Not a lot, but remember, we haven't only been given one piece of data, we've actually been given 2 pieces of data. The first is a mass here of chlorophyll. The second is, in fact, the chemical formula of chlorophyll. If we're given a chemical formula, what can we determine from that? We can get a molar mass, okay? And once we've got a mass and a molar mass, then what can we do with those? Well, remember, here's an equation that contains both mass and molar mass. Very, very important equation, that one. And one that we're going to be using in the majority of stoichiometric problems that we do. We're given a mass of chlorophyll. We're given essentially now a molar mass of chlorophyll. Sure, we've got to go and work it out ourselves, but we've at least been given the chemical formula to be able to do that. So we go to our trusty periodic table. The first thing that we're going to be doing is calculating the molar mass of chlorophyll, and that is going to be 55 times the molar mass of carbon, which is 12.01, plus 72 times the molar mass of hydrogen, 1.008, plus 5 times the molar mass of oxygen, 16.00, plus 4 times the molar mass of nitrogen, which is 14.01, plus the molar mass of magnesium, which is 24.31 grams per mole. And if you add all of those up, you get 893.476 grams per mole for the molar mass of chlorophyll. This is a decent sized molecule. So what can we then do with this? Because now we have got our mass of chlorophyll, 1 gram, and we've got our molar mass of chlorophyll, 893.476 grams per mole. And you might say, well, yeah, that's all well and good, but the question asked about oxygen. Okay, it's not asking us about chlorophyll as a whole, it's asking us about oxygen in chlorophyll. So why is any of this relevant to the question that has been asked? Well, that all comes back to the chemical formula of chlorophyll that we have here, as we will see in a second. But first, the first thing that we're going to do, because essentially there's nothing else that we can do with the data that we've been given, is we are going to calculate the number of moles of chlorophyll that 1 gram corresponds to. So let's then go ahead and do that. The number of moles of chlorophyll is going to be equal to the mass divided by the molar mass. We've got 1 gram, or to be consistent, we've got 1.00 grams of chlorophyll. The molar mass of chlorophyll that we worked out just before, 893.476 grams per mole. And we do our calculation, and that comes out to be 1.12 times 10 to the minus 3 mole of chlorophyll. Where to from here? Because remember, the question was not about chlorophyll per se, it was about oxygen in chlorophyll. And it was asking what mass of oxygen was present in this 1 gram of chlorophyll. So, where do we go? Now you'll notice that we don't have a balanced chemical equation here to do a mole ratio thing with, as we have done in other videos in this series. However, what we do have is a chemical formula. And that is going to sort of serve the same purpose as a balanced chemical equation in this problem. Because we know from the chemical formula of chlorophyll, if we've got 1 mole of chlorophyll molecules, that 1 mole of chlorophyll molecules is going to contain 5 moles of oxygen atoms. And that's really important. So in the same way as you can get a mole ratio from a balanced chemical equation, you can also get a mole ratio from a chemical formula. So what we're saying is, for every mole of chlorophyll we have, we're going to have 5 moles of oxygen atoms. So we've done our calculation now. We know the number of moles of chlorophyll that we have. So therefore, the number of moles of oxygen atoms is going to be equal to 5 times the number of moles of chlorophyll. And that's going to be equal to 5 times this number here, 1.12 times 10 to the minus 3 moles. And that is equal to 5.60 times 10 to the minus 3 mole. And now we're very, very close to our answer. This is the number of moles of chlorophyll here, 1.12 by 10 to the minus 3. This is the number of moles of oxygen that we have in that number of moles of chlorophyll. We're one step away. We have our number of moles of oxygen. We know the molar mass of oxygen, so therefore we can get a mass of oxygen now. So how do we do that? We say, okay, so the mass of oxygen is going to be equal to the number of moles of oxygen, this number here, multiplied by the molar mass of oxygen, and that's going to come out at 5.60 times 10 to the minus 3 mole of oxygen, multiplied by 16.00 grams per mole. That's your molar mass of oxygen, and that comes out at 8.96 times 10 to the minus 2 grams of oxygen. Okay? And there's your final answer for that one there. Okay? So, what this is showing you is you don't necessarily need a balanced chemical equation for all stoichiometric problems. A chemical formula will do you just as well. So the chemical formula of any substance tells you essentially the mole ratio of atoms that are present within that particular substance, okay? So we've done our calculation. In 1 gram of chlorophyll, there is around about 0.09 grams of oxygen. And that's a reasonable answer if you do a sort of a quick mental calculation based roughly on the molar mass of this whole thing here. Okay, so there's a nice example of using a chemical formula to obtain stoichiometric information. Let's have a look at, well, I guess it's a similar-ish kind of problem. There's a molecule called ATP, adenosine triphosphate. So this ATP molecule, very, very important in biological energy production. It, as the name suggests, contains the element phosphorus. By mass, that is 18.32% of the whole ATP molecule. And we also know there are 3 atoms of phosphorus per molecule of ATP. So our question then becomes, what is the molar mass of ATP? Okay, so a slightly curly question here. How do we go about this? We look at the data that we're given. And really, in this case, we haven't been given a heck of a lot of data. The only thing really that we've been given is the fact that phosphorus comprises 18.32% of the entire mass of an ATP molecule. And we're also told that every ATP molecule contains 3 atoms of phosphorus. So how do we use these data to calculate what the molar mass of ATP is? It's not immediately obvious. But let's start off by saying, okay, 1 molecule of ATP contains 3 atoms of phosphorus. So 1 mole of ATP is going to contain 3 moles of phosphorus. So what do 3 moles of phosphorus weigh? Okay, because we're after a molar mass. Again, if we don't know where to start, how can we do anything with the data that we've got? We can at least find out what 3 moles of phosphorus is going to weigh. Using our trusty equation again, so the mass is equal to the number of moles times the molar mass of phosphorus, which is 3 moles, multiplied by the molar mass, 30.97 grams per mole, and that comes out at being 92.91 grams. Okay, that's what we can do thus far with the data that is given to us. We're saying, right, in 1 mole of ATP, we have 3 moles of phosphorus. 3 moles of phosphorus weigh 92.91 grams. Now, we're also told that the phosphorus constitutes 18.32% of the mass of ATP. So in other words, 92.91 grams is 18% of the total mass. So therefore, to get the total mass, let's take 92.91 grams multiplied by 1 over 0.1832. That's your 18.32%. You multiply those two together and voila, you get your answer, 507.2 grams. Okay, a little bit of a curly question, that one. Not necessarily blindingly obvious where you begin, but this is a sort of stoichiometry question that requires a little bit of thought. Got to think your way through things very often in stoichiometry, but again, notice that we're using that one equation in stoichiometry, this equation here. So the equation that relates mass, amount, and molar mass. Extraordinarily useful equation. And as I've said in other videos, pretty much you're guaranteed to be using this equation in nearly all of the stoichiometry problems that you're going to be solving. So hopefully that all makes some sort of sense. If it doesn't, maybe hit your textbook, find a few sort of similar problems of this ilk and go through and do those. And we'll see you next time.